Hello, let me check. Hello, hello. Yeah, it's working now. Sorry, guys. Some issue just came. Yeah. So row set dot remove, and we need to give that object at that time. So instead of clear, we will say to remove. Yeah. So at only once it will get remove out of that. So if that character is present, DVDF. What if we have VDDF? So we are D and D again. So what we need to do? We need to remove till that element is not completely removed from the hash set. All right. So at that time, at in that case, we need to use a while loop. So while that set contains this element, that till that time we need to say just remove this character, right? So set dot remove s dot character at this. So we need to remove this character till it is present. So let me show you. Let's say we have this. We have it like this. V D. All right. So at that time, the algorithm we have right now, this one. Okay. So if the set is already containing that thing, is my YouTube again? I don't know what is happening. Okay, but still, uh, still we can solve the questions. It's not with the questions till now. All right, so let me just, yeah. All right. So let's say we have this. We have a left pointer. We have a left pointer. No. We have a left pointer here and the right pointer here. So at this time, we have v in our hash set? No, we will increase it and we will go further. Do we have d in the hash set? No, and we will update the size as well. Do we have d again? Then at this time, you will say yes, and what you will do is you going to remove it till the d is not present in the hash set. Okay, so at that time you will remove it, you will remove this one, so you will iterate the left pointer till r, and you will remove that uh, d from the hash set. So this v got removed, then you came to d. Still you will check if this is present, so r of d is present, then you will remove this as well, and then you will check that this d is not present. Now you will add new d and compare the price. So is 2 is greater than 1, then no, we will not be increasing the price, not the price, sorry, the size. And then we will check that if f is present, then no, f is not present. What kind of f is this? Yeah, so the f is not present, and at that time we will uh, check the length. So at that time also the length is not there. Let's see, let's check for the thing. So it's saying that index out of bound for length this. So all right, so we need to also so see that uh, and left can be smaller than or equal to r. Let's check now. Still s caret set dot contains smaller than. On this input only a b c, and we got a, so we have removed l from the character. Note l from the character b c 0. Oh, sorry, we need to increase it, not decrease it. Lol. Let's check now. So yes, yo, so we have solved this one as well. Okay, and it took It took more, but if we can do this again, let's see. Yeah, it's taking much time. Let's see if we can uh, solve this in lesser time complexity, but yet we are able to solve it, right? Let's let's see what the legend says. So what is the recommended time complexity? You should aim for a solution with big of n and big of m. Time complexity, the length and this length of the string, and m is the this. A brute force is this. Okay, but we don't need to take care of the brute force because we have done it already in the right time complexity. Uh, I need to check this solution if it has. Tell me its space complexity. So you have ChatGPT, you can ask it from him. Minimum of n or k in Unicode for arbitrary lol arbitrary whatever is this called. It's saying in worst case it will be big of n, and if we assume ASCII input, that simplifies to big of 1. Okay, so the algorithm we have right now can be big of 1 as well, depending on the character. If it is only using ask what is saying, if we assume ASCII input, that simplifies it to big of 1. Otherwise, if we have Unicode or arbitrary whatever it is characters, then it will be uh, big of n. So that's good. Now we will see the solution because I want to see what he is also doing. Sliding window optimal. So hash set length and res. What is this res, bro? Okay, so he has used this R pointer. L is this. While contains, we will remove this. We will add this. We will maximize this. What it suggests that it takes big of m space complexity. Still, it takes big of m space complexity. Sliding window optimal. At this time, he took this res contains. What the fuck is this, bro? He has used hash map in this character integer and map dot contains key at this. At that time, map max gets as mp put s dot caret. But why it is optimal? Where n is the length unique? Let's see the video.
Let's solve LeetCode 3, longest substring without repeating characters. We're back to a classic LeetCode problem, the third one. So this one's pretty simple. We're just given a string and we want to find the longest substring without any repeating characters, right? Like how these three don't have any duplicate characters, A, B, C. This one has two A's, so this would not count as a substring without repeating characters. And we only need to return the length of this substring. So the first idea that comes to my mind at least is, so just check every single substring, check if it has any duplicates. If it doesn't, then we're just going to take the longest one of those strings and return the length. So how would that algorithm run? Okay, first we'd start at A. We want to get every substring starting at A. So just this one A, well, that doesn't have any duplicates. AB, that doesn't have any duplicates. AC, that doesn't have any duplicates either. And then we get to this first duplicate, A. We have two A's now, but remember, we're checking every single substring starting at this first A. So we're going to keep this algorithm going, even though we don't have to. Every substring we get after that, like, see how we're doing it? Every single substring after is also going to have duplicates. So do we even need to check all of these starting at value A? This is the repeated work that we're going to eliminate with our very fundamental technique, the sliding window. So we want to only check substrings without any repeated characters. So let's actually just do that. Let's make sure that our window, right, our subarray, our substring is always not containing any duplicates. So once we get to this next A, we're going to say, well, now we have two A's. So we need to start removing from the left. We need to start shrinking our sliding window until we no longer have duplicates. So I'm going to say remove this one from our substring. Now our substring runs from here, from the B, all the way to the A. Now it's perfectly valid, so now we can keep going. It's still only length 3 though, so next we're going to add this B. But wait a minute, now we have two B's. But my question is, how would we even know instantly whether we had a duplicate or not? Well, we can use a set for that. Sets will only contain one of each character, so we'll automatically know if we have a duplicate. This character remove values from our set, but that's a very quick operator of n, because potentially every character in the string could be unique, and we'll add all of them to our set. And I didn't really show it while we were going through the problem, but we would want to maintain what's the longest substring we found. In our case, it was obvious that the longest we found was of length 3. So remember, the first thing we need to do is get a set to make sure we have all the characters in our window. So I'll call it character set. And we're going to do a sliding window, so we need two pointers, a left pointer and a right pointer. Get to water character and gets rid of it, so we can determine if this was.
That's what I've done. All right, we'll just mark it and go further. Okay, so the third question is longest repeating character replacement. What the heck is this, bro? You're given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Who makes these kind of questions? Let's just go with the approach first. Today's literally good, I would say. I'm able to solve some questions by myself, and literally medium questions. Although I've just solved one medium and one All right, so we have this one, have some water. All right, so given an array, you have and you have this as well. So you can do at most two replacements, and then you need to check, like, then you need to check if its length is greater or not. So let's make the array again. I'll do it somewhere here. We have an array of a. What the heck? Just a second, guys. Yeah. So we have a, then we have b. Let's do this. Then a, then b. All right. So we have this array. Let's see how we can do this. Again, we will be having max length. So let's say we have this max length of 0. What it asked. So you are given an string s and an integer k. You can choose any character of the string and change it to any other uppercase English. You can perform this operation at most k times, then the length of longest substring containing the same letter you can get after performing the above operations. So at this time you can choose any of them, and you can just replace it. So it will become a, and then it will become a again, and at that time you can have like the maximum length of repeating characters. Replace the a two a's with two b's or vice versa. Alright guys, and here you have AAB, AABA, and at this place replace the 1A in the middle with the B and form A B B A. The substring B has the longest repeating characters, which is 4. There may exist other ways to achieve this answer too. Obviously. So from this, let's have this only, bro, because that thing will confuse us. I can either, yeah, let's use this. And we will have this here as well. Sorry, A, B here, brother. A, B, A. All right, A, B, A, B, B, A. Yeah, so we will be having two pointers here as well, left and right. Okay, but before than this, I guess like getting the frequency of the characters will be good here for for like getting this idea like which character we need to place, which which character we need to replace, and how we can do that. Now I will tell you. What we will do is we will create a window. We will start iterating from 0th position. Okay, and we will check like till how till how much till when we are getting the same character. We will be adding we will be keep like incrementing the character count as well. All right, and we will check the length. So let me just guess what's the best possible way of doing this. Character of A, then B, A. We have done operation of A again. B. So we got how much length we got? We got what is the K here? K is only one. So at this place we already have 1K. No. Okay, leave it. It's one. It's 1. Okay, so one time we can do this. Let's go with this. So we have a first, and how can we also check that we have done this? So we can decrement this as well. So here we got this k, we can decrement this as well. So let's say we have shifted our pointer to this at this time. So at first we will do this. No, yeah. So we won't be able to increment uh, this maxel until and unless we do perform this operation of replacing a character. So once we replace a character, we will do this operation, or otherwise change it at the most k times. Let's do uh, uh, the do it the other way, like until and unless this k becomes 0, we want to be updating this maxel. Once it becomes 0, that means all the characters got replaced, and at that time we will be updating this maxel. Okay, this is the simplest part of the problem. Now the harder part of this is we need to do this for the second string as well. So second substring as well, after replacing the other character. Let me tell you. So in this case we will be updating this b to a. Okay, so once this a will be once this b will be updated, then we will get a length of this, right? We will get a length of this, and we will say that the let me tell you just by doing this. So we came here, we did one operation. Let's mark this became 0, and now once it became 0, we will check for the string which are there, which we do not need to replace, but we can add it in our hash set. Let's say hash set, because it is of the same character. So we have added this. Now we will check that if this is edible to this hash set, then no, it's not, and at that time we will increase the max length to 4. All right, so we also need to have a hash set. So hash set, nice, hash set. That's the worst writing it can be. I will say hash set. Okay, so it will be like this. So we will say not hash set, we cannot add hash set to the but we can use a array list instead, right? Because array list can also give us the contains feature and can add the duplicate as well. Hmm. But can we use hash set as well? And in this question, one more thing is there. How we gonna know that which character we need to replace? Like, will it be always A or B, or it can be anything? Then we need to check like which character is there. All right. So at this time it is this. We have incremented this here as well. We will say that we will use array list. Let's use array list for now, and we will see if we need to change it or not. So we will use array list. Alrighty. Yeah. So we got one A, then A again, then A again, and this is kind of a repetitive task, but we can optimize it later. Let's go with this only. So what we have done, we got this thing and we have just updated it and uh, pushed it to array list, and then we check that but yeah. So we will check if A is present or not, because we need to keep keep it the same as others as well. But still, if B is there, all right, I got it now. Let's check this. So we have incremented this, right? Now what we got? We got B here, okay? And we have zero kth operations, right? So we have set this maximum to this to here only. Now what I will do, I will keep removing this A, okay? I will keep removing this A till the place of B, okay? And what I will do, because uh, I already have this A here, and the B cannot be replaced. So there should be a way that we know that this is the index. I mean, this is the index we have A already, and we need to replace it. Let's do this. So I got here. I will remove this. I will remove then this. Then I will say, is this present here or not? If this is not present here, then add this, and then we will come to here and we will check, or what I can do. Yeah, this part is really tricky, you know. What approach I can use? I can put A here and then here again. Now I will come here to B. A, A, B, B. I'll move my pointer to that B again, and then I will again be doing the same part till I get the max length. Yeah, in that way it can be done, right? So let me tell you what I'm thinking. So first, so resetting this array list will be the best of what we can have. Or instead of this, I can just have one character int, right? And then, yeah, that can I do as well. So let's say we have two pointers, int l equals to 0, int r equals to 0, and I have int max length, longest. We need to have a longest, right? Longest it will equals to 0 as well. Then what I will have is a character char of s dot char at 0 for now, which we can change it later. And while r is smaller than s dot length, what we will do is we will be keep checking that if ch is equals to s dot char at of r and k is greater than 0. So at yeah, let's if ch is this, character of r is this, then just keep incrementing r. Okay, else do what? uh, if this contains this, then increment r, else do k minus minus, else if k is already, if k is 0, then do what? So just a second, guys. Yeah, so if the k is 0, so at that time, what I want to do is, we got the replacement, and if ch is still there, then we will keep iterating this. If we got k0 at that time, we will do this max of length equals to math dot max dot max of uh, and I will say r minus l. That's what we will do first, and we will update it, and then we'll say that while ch is equals to s character of l, just keep iterating to the l. Once it's done, okay, then do r equals to, sorry, l equals to r, else k minus minus plus plus. All right, so let's say in here, if I have converted this b, so till we get this b here, we also need to know that, like, how many conversion we had previously. Yeah, so for that we need to conversions equals to k, I guess. So instead of k, I can decrement conversions, right? And while I'm doing this, I will check. So while this is not done, I will say that conversion also needs to be changed, but it will always changing for once only, right? So I will say I will say add conversion for once only. So we will get one conversion only for this, and then if that happens, then again this will start incrementing, and if once the conversion gets this, so what I can do, I can do this, and I will take this part to here. Right, so what I've done here is if character is not equals to this, then conversion it has changed, and I also need to change the character here, which is s dot char at l. All right, bro, this solution is the least optimal one, bro, but let's see. So I have two pointers, L and R, and while R is smaller than length, R will keep updating. Okay, when it will not update, when until and unless the character is not equal to this, then we will see for the conversions if we can do. All right, so if we see any character which is not equal to this, at that time we will do conversions, otherwise R will keep iterating. If the conversion count gets 0, okay, at that time we will uh, update the length, update the maximum length with the conversions. Okay, now I will shift the left pointer to the place where character match ends. Okay, so so that will what this will do, this will only do one conversion. I mean, this will only add one conversion, let me tell you. So uh, let's say the above one is our left pointer. Okay, see, so the right pointer is here, we have added this. Let's just forget this one, buddy. Instead of array list, we have a character now. We have a ch which has this character. Okay, so let's say our pointer left is this. We have shifted it to here. Okay, and it is a for now. So we checked it is a or not. So at here we sorry, not here. Yeah, so at this place I'm talking about. So here we checked if character of L is greater is equals to this, then we will shift it again, and then we have shifted it. We checked that it is equal or not. It's not equal, so we have given one conversion plus. The character became the new character of B, okay, and L is placed at R again. It is placed at R again, which should not be the case, but let's see if it will work or not. Okay, so R is and L both are here. Let me erase them too. Okay, now let's say, so now we will again keep iterating. So we will check if this uh, is if this character is equals to this at this time. It's not equal. It will come here. It will uh, do the conversion. Okay, so we don't need this actually. I got it. We can use k only instead of conversions. So we are k. So we will increase the k. Okay, and then we will shift again. But one thing here is that if again we get the same thing, right? Like if we get that the second pointer is not also 2. Okay, leave it. So k again, we have changed this character, placed R, and then again we have checked uh, it is equal, it is not equal, so we have uh, decreased the conversion. Then we checked it is equal, yes. Then we have increased this. Let's see, guys. Then I will simply return this maximum length and wait for the answer. While sorry. Okay, wow. So at this place we have A, we have B, output is 0, expected is 4, we have B, it could be 4, I mean we could have converted it. Hey guys, please subscribe as well. There are two peoples watching. One might be me only because uh, watching this on my phone. All right, so we got A, B have done one conversion, then A again, then the B have done another conversion. Okay, that's it. another conversion, and we never got to. Oh, so at this place also we need to check that if this has been done. Right. So if it is placed here, do this, take maximum of length if we have reached. So do we need to add this one? So let's say if r equals to s dot char at -1 and k equals to 0 as well, at that time return l r minus l, or not l, at that time you will do this and then return l. Or one more thing, instead of this you can go here. Character is not same, because after this it never came back, right? Yeah, it worked out. Let's see. It's wrong here. Output is 0, expected is 4, replacement is 2. You're given an integer, you can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of longest substring containing the same letter you can get after performing the above operations. Oh my god. Let me just submit it again. Let's see. So I need to check the length anyways. And not only else, you need to keep updating. If character is not equal to, otherwise if it is equal, then you will keep updating this length. Will it work? Output is 3, expectation was 4. Why it happened? uh, at this time A, then B, A replaced B, so A, it got here, it decremented one, and then got here again, it is 2, now it is 3, okay, then it came here, it decremented again, and it should become 4, no, A, B, A, 0, 0 minus 0 is 0, R is smaller than S dot length, max this, it never came here, that's why it's not incrementing here, but did again, okay, and the max of L, R minus L, R minus L plus 1 will work, but how it, sorry, it will not work, bro, it will not work like this, it worked like this, what kind of coding I am doing, at this time it's 0, output is 3, no, that will not happen. If there is key, then expected is 1. If this is what we got, and why there is one expectation, let me tell you. If we can do this, why not? If k is 0 and string, hey guys, how are you? Oh, sorry, not string, s dot length, string dot length is greater than 0, then return 1, else what? But this is so, we could have used something else. We need to shift it. A, B, A, B, we have 0, we are expecting 1, So we just came here, A, then the right pointer moved here, but it saw that we cannot replace it. B is 0. If it is 0, then it will fall here, right? It will do this and increment this part. Then this will happen. But I don't want to take this thing like max. Let's go here. I guess I should drink some water. My video is getting fluctuating. Sorry for this. Right. Uh, I won't be wasting too much time on just looking for the solution. We will check for the code. Okay. If we don't get any solution from this, so we have A, B, we have K. Let's just take this to separate. We have K equals to 0. So at that time, we have two pointers left and right. And from our algorithm, we have just came here. Okay, we just see that left pointer has common character. At that time we will just take the length, which will be right minus left plus 1. It will become 1, and we will increase it. At that time it will check, that so yeah, we need to have a conversion int. Why? So let me just tell you. Int conversion equals to k. Sorry to sorry for replacing it previously, because I thought that we don't need one more variable, but we are needing it now. So why are we using this? We are using this conversion because we got a case where k can be 0, and here we were increasing this conversion when we were iterating left pointer forward. So for now we will check that if this is not this and k is greater than 0. Now let's see. I think still it will fail, but let's see what happens. Conversion. Yeah, it failed again. The output is 1 and it expected 4. And why that happened? That happened because output is 1, expected was 4, and but in this case it will work. Okay. Oh, sorry. This is not required now. Okay. Expected was 3. We got 4. Uh, let's say we have already a 1 string, and if s dot gth is smaller than equal to 0, or let's just say smaller than 1, then return 0. It should work as well. It Why? Because this pointer never came here. If Okay, guys, I have uh, put so much time in it. Let's just look for the question, and that's what you should do, guys. Okay, so you can set a timer of 1 hour. I haven't set it because